Hey everybody, I wanted to spend a little bit of time and talk about some of the beginning concepts in kinetics. Kinetics is kind of an interesting part of chemistry because it deals with the speed at which reactions happen. And up until this point in chemistry, we've probably only been worried about the fact that there are reactants, and those reactants then form compounds, and then or form products, and then it's all kind of over with. There's a whole bunch of stuff that happens in between the reactants and the products, and that's a lot of what kinetics deals with. So here's some quick ways to describe what kinetics is. And not only does it describe what happens kind of in between, or how long it takes to get from reactants to products, but it also addresses the mechanism or the pathway with what happens between the reactants or products. For example, if I have reactants X, okay, let me back up. See, even I'm an idiot sometimes. So if I have reactants X plus Y, we're used to just seeing those react to form A. Well, in kinetics, what we're going to do is we're going to look and we're going to say, look, here's X plus Y. And those are going to travel through some sort of energy path and get to the products A. Okay, so what's happening in here is the pathway or the mechanism of the reaction, and kinetics does deal with how the reactants get to the products. And it's really interesting stuff. You could spend your whole life dealing with kinetic issues and kinetic chemistry and for just one reaction. So anyways, let's move on, I guess. Okay. Talking about the basics, kind of the very basics and introductory stuff in terms of kinetics, we're talking about the speed of a reaction. And so here, let's discuss what the rate of a reaction is. Okay, and so the rate of the reaction is the speed that the reaction happens. So if you've ever taken physics, you know that rate is really just something happening over time. It's how fast something changes, and that is based on unit time. And the rate of a reaction is that same concept, where we take how much the reactants are changing, and so that's the change in concentration here, and we compare that to the change in time. And so what we get is we get delta concentration over delta t, lowercase t, and when I draw my t in kinetics, I do t with a little dingus here. Okay, and just so you know, that dingus has a name. It's called a terminal, but I'm gonna call it a dingus because that's more fun. Okay, and so when we measure how much the concentration changes, okay, we're measuring that value in molarity. So you have to be familiar with molarity in order to do some of these chemical kinetics problems. And unlike a lot of chemistry problems, it turns out that when we talk about time, time can be measured in just about any unit. Time can be measured in, the base unit is seconds, but I've seen kinetics problems specifically that are in minutes or hours, sometimes years. So you have all sorts of different units of time that you can measure things in. So it doesn't always have to be converted in this case to seconds. Okay, and that makes kinetics fun. No, that's not what makes kinetics fun, but that's, it makes it a little easier to manipulate because then you don't have to do conversions for time, because time conversions are a pain in the neck. So that's a little bit of kind of the introduction about what kinetics is, and how we determine the rate of a reaction. Okay, we're gonna in a little bit we're gonna get into some of the more details of this, but it'd be really good if you knew that kinetics has to do with the rates of reaction. Okay, so have a great day.